Okay, AMC 8 2020. Let's go. So problem number 1. Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. How many cups of water does he need? Okay, so twice as much sugar as lemon juice, and then he uses 3 cups of lemon juice. So 3 times 2 is 6. So I guess 6 cups of sugar, but then 6 times 4, 24, obviously, because 4 times as much water as sugar, so 24 cups of water. So E is our answer there. Problem number 2. 4 friends do yard work for their neighbors over the weekend, earning $15, $20, $25, and $40 respectively. They decide to split their earnings equally among themselves. In total, how much will the friend who earned $40 give to the others? Okay, so 15 plus 20 plus 25 plus 40 is, it's gonna take a second here, 100, right? So 100 divided by 4 is 25. So then 40 minus 25 is 15. So the answer is C. Okay, problem number 3. Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? So 6 feet by 8 feet, so the area is obviously 48 feet squared. And then 4 strawberry plants per square foot, and then 10 strawberries. Okay, so 48, I can't write here. 48 times 4, okay, 192, and then, so then 192 strawberry plants, but then 10 strawberries per plant, so times 10 is D. Did I skip a problem? I hope I didn't. Okay, 3 hexagons of increasing size are shown below. Suppose the dot pattern continues so that each successive hexagon contains 1 more band of dots. How many dots are in the next hexagon? Okay, so let's just get a different colored pen here. So there's 1 dot here. There's 1 plus 1, 2, 3, 4, 5, 6 dots here. Now there's 1 plus 6 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots there. So we can already see that that there's a pattern here, multiples of 6. But if we really want to be careful, we can technically draw all of this out. I'm not going to do that here. You guys can do that. But anyways, the next one's going to be 1 plus 6 plus 12 plus 18. And then that has to be 39, right? So the answer is C. Problem number 5. 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? Okay, so 3/4, that's pineapple juice, and then each of 5 cups. So we're going to need to divide that by 5. So 3/4 times 1/5, 3/20. Now we want to convert that to percentage. So 3/20 times 100, 5, 15. So that's 15%. And the answer is C. Problem 6. Aaron, Darren, Karen, Marin, and Sharon rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car. Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. At least 1 person sat between Karen and Darren. Who sat in the middle car? So we have 1, 2, 3, 4, 5 cars here. Let's just say that's the front and that's the back. Okay. Marin sat in the last car, so we're gonna have M there. Aaron sat directly behind Sharon. So somewhere here it's gonna have to be Aaron, then Sharon. So, and then Darren sat in one of the cars in front of Aaron. So we know that we're gonna need to leave at least 1 thing blank for Darren. So then we have 1 more case here, 3, 4, 5, and then M there. So we can say SA and then SA. So then in this case, Darren is going to have to sit either here or here. So it's, and then where is that? And then there's Karen left, so it's gonna be like this, or Darren and then Karen. But then it says at least one person sat between Karen and Darren. In this case, nobody can sit between Karen and Darren. But now in here, what we can do is Darren can sit here and Karen can sit here. Two people are sitting between Karen and Darren. So this case works. And Aaron is sitting in the middle car. Okay, problem number 7. How many integers between 2020 and 2400 have 4 distinct digits arranged in increasing order? For example, 2347 is one integer. Okay, so we have 4 digits here. 1, 2, 3, 4. And we have 2 here. So that's going to be 3 or greater. But it cannot be greater than 4 because it's 2400. So we know that this has to be 3. And then now here, we can basically choose anything from here. So it's going to be start from 4 and then something's going to go there, right? But what we need to keep in mind here is that it's 4 distinct digits. So it cannot be, let's say, it cannot be like 4, 4 or 5, 5. It cannot repeat. So this is actually pretty easy because 4, 5, 6, 7, 8, 9, there's 6. And then there's 6, but if we do 6 choose 2, that basically works out. So then that's times, okay? That's 15. But if anybody does not know what this is, you can technically test every case out, but obviously knowing this would be better. Anyways, 15 is the answer. Problem number 8. Ricardo has 2,020 coins, some of which are pennies, 1-cent coins, and rest of which are nickels, 5-cent coins. He has at least 1 penny and at least 1 nickel. What's the difference in cents between the greatest possible and least possible amount of money that Ricardo can have? So greatest possible, we're going to need to maximize the number of nickels, and least possible, we're going to have to maximize the number of pennies. So if we go with greatest possible, there's at least 1 penny, at least 1 nickel. So the maximum number of nickels is 2,019 nickels. And then there's plus 1. But that they're nickels, so we have to times 5. Okay, this is... Anyways, that's... What's the difference? So we're not going to do the math here because AMC usually does not make us do nasty stuff like this. And then the minimum is going to be 2019 plus 5. That's 1 nickel, 2019 pennies. So basically what we need to do is we can express this as 2019 times 1. So 2019 times 5 plus 1 minus 2019 times 1 plus 5. So if we do 2019 times 5 minus 2019 times 1, that's going to be 2019 times 4. And then 1 minus 5, that's going to be minus 4. Okay. And then if we do, now it's 4 times 2019, we can also say that. So we can also do 4 times 2018 here because we're subtracting 4. That is still pretty nasty. Disappointing. Okay. Oh, nope. Okay. So, took me a second there, but the answer is C. Problem number 9. Akash's birthday cake is in the form of a 4x4x4 inch cube. The cake has icing on the top and the 4 side faces and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes, each measuring 1 by 1 by 1 inch, as shown below. How many small pieces will have icing on exactly 2 sides? Okay, so we can mark where the icing is going to exist. So there is no icing on the bottom, top and the 4 side. Okay, so icing's gonna be there. Okay, icing's gonna be on this side, that side, and then that other 2 sides there, right? That was pretty nasty drawing. But what we can say here is these four faces, and those four faces, those only have icing on one side. And these corners, they have icing on three sides. So we don't want those, okay? But these corners, they have icing on two sides because there is no icing on the bottom. So we have these corners, 2, 3, 4. So we have 4 plus, if we just quickly erase those there because it's confusing. Those faces, these faces, they also have icing on two sides because there's icing on this side and this side, this side, this side. So that's two sides. So there's gonna be, and then there's also gonna be those faces. Same reasoning. Okay, now that is, we have 2 times 4, that's 8 there, and then there's also 8 there, so 16. Okay, and that is basically it. 20. So the answer is D. Okay, next problem. Problem number 10. I don't know why that started there. That's pretty annoying. Okay. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put the steely and the tiger next to one another. In how many ways can she do this? So there's A, B, S, T. Okay, display, but does not want to put the steely and the tiger next to one another. So the way we can get this is we can get the total amount of waste. We can use complementary counting, which is basically total amount of waste, total, minus the opposite of what we want, op. In that case, what we want, the opposite of what we want is when the steely and tiger are next to one another. Okay, so total is just going to be 4 factorial. And steely and the tiger next to one another. So 1, 2, ST. We can think of that as one block, one marble, okay? And then we have A, B, or something like that. So this is just the number of ways to put 3 marbles together. So that's 3 factorial. But then we can switch around the T and the S. So right, that's just going to be 2. Okay, 3 factorial times 2. Okay, so then that's 4, 3, 2, 1, 3, 2, 1, 2. Okay, that's 24. That's 12. So 12. C is the answer. Okay. Next problem. After school, Maya and Naomi headed to the beach 6 miles away. Maya decided to bike while Naomi took a bus. The graph below shows their journeys, indicating the time and distance traveled. What was the difference in miles per hour between Naomi's and Maya's average speeds? So average speed, what they're basically asking for is the total distance over total time, right? So Maya did how many? 6 miles in 30 minutes. So, but then it's miles per hour. So 30 minutes equals 1/2 an hour, right? So distance over time, that's 12, right? Okay, and then Naomi, also 6 miles. Wow, my computer is very laggy right now. I don't know what's happening. And then in 10 minutes, but then that's 1/6 hours. So that's 36. Let's put the units. Okay, so 12 miles per hour, 36 miles per hour. So it's difference, right? Difference is 24. Okay. Problem number 12. For a positive integer n, the factorial notation, n factorial, represents the products of the integers from n to 1. Okay, we all know that. What value of n satisfies the following equation? So 5 factorial times 9 factorial equals 12 times n factorial. Okay, let's just write that out. So 1, 2, 3, 4, 5. Okay, times 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so basically this is kind of, that's too long. We don't want to do that. So that's 5 factorial. Okay, we know that that's 120. Okay, and then 9 factorial, we don't want to calculate that, right? So then we basically have 120 times 9 factorial equals 12 times n factorial. Okay, so now if we have that there, 120, so that's 12 times 10 times 9 factorial, and then 12 times n factorial. Okay, so we know that 10 times 9 factorial is 10 factorial, so 12 times 10 factorial. So n equals 10. Okay. Sorry, my computer was very laggy, so I don't know, that might have not been as smooth as the previous problems. But okay. Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? Okay. So then there's originally 18 purple socks. Let's kind of zoom out here. 18 purple socks, and then now let's just say he adds like X purple socks. Okay, and then the total amount is, there were originally 6 plus 18 plus 12, but we added X purple socks, so that's X. That's the probability that there's going to be a purple sock. Okay, so that has to equal 6 over 10. So we just kind of solve this. We don't want 6 over 10. That's not simplified enough. That's 3. Okay, that's weird. 3 over 5. Yeah, sometimes my pen is a little bit weird. Anyways, so 5, 18 plus X equals 3. 6 plus 18, that's 24 plus 12, 36 plus X. Okay. So, okay. We have to do this. 18 times 5. Okay, so that's 90 plus 5X. 36 times 3. Okay, 108 plus 3X. Okay, so 2X is 18, X equals 9. Okay, so the answer is B. Kind of, okay, that's still okay up to there. Okay, so there are 20 cities in the county of Newton. Their populations are shown in the bar chart below. The average population of all the cities is indicated by the horizontal dashed line. Which of the following is closest to the total population of all 20 cities? Oh, okay, so now that is the average. So we can recall that the average is like, okay, so the sum over how many cities there are. But then there are like 20 cities, right? So, okay, so that's like 4,600, 6,000, that's about 5,000 there. Just mark that as 5. So then so we can say that that's the middle. So that's 4,500. Okay, but then that's 4,500 and 5,000. The middle between 5,000 and 4,500. Okay, so then that's 4,000. Okay, 4,750. So that's 4,750. It's a rough estimate. We can go with that. Okay, so that's the average. Okay, so that's 4,700. What? Okay, 750. Okay, multiplying 20 on both sides equals. Okay, we don't want to make a mistake, right? Okay. Okay, so and then there are two more zeros, so 95000. So the answer is D.